Hi everyone, welcome to the second video in this series, which is Introduction to Databases. So in this video, we'll be going over some of the basic concepts of databases, why we need them. We'll also look at where they're used, and while doing so, we'll cover some real-world examples as well. So first, what is a database? A database is an organized collection of structured information. That is the formal definition. But more simply put, it's an organized way to store information. A database is usually managed by what is called a database management system, or DBMS for short. And what a database management system does is it allows you to add new data, modify existing data, and in general just manipulate the data. So before we get into more details about databases, let's take a look at this scenario. Suppose there's a student A who's studying in college X, and he's taking two different educational programs at the same time. So he's studying computer science and history. So he goes to the computer science department and he registers for his classes and he gives all of his details. So he gives them his name, his age, his address, his phone number, and the subjects that he's taking. And similarly, he goes to the history department and he gives them his details again. So he registers at the history department. He gives them his name, his age, address, phone number, and the subjects he's taking. So there's a slight problem here, which is that you are storing most of the information twice, right? So you can see that you're storing his name, the age, the address, the phone number. You're storing that twice, once in the computer science department and once in the history department. So you're using a lot more memory because you're storing everything twice, right? And memory is a precious commodity in a database. And another thing is, what happens if he updates his phone number in the CS department but not in the history department? So now you'll have two different phone numbers. So how will you know which one is the correct one? Which one is the most recent one? So this is just for one student. So imagine this kind of thing happening for 100 students or 1,000. It's impossible to keep track of what is correct and what isn't that way. So we've identified a problem. How do you know which data is correct and how do you know what is outdated, right? How do you know which is the most recent data? And this problem just gets compounded when you have large amounts of data, when you have many students. So what a database does is it normalizes the data, and it basically helps you avoid inconsistencies like this, and it makes sure that you have the same data stored across the board everywhere. So you avoid inconsistencies like this, you avoid duplicates. So now let's look at another example, right? Suppose there's this bank account, a joint bank account that's shared by two people, person A and person B. There's 1,000 rupees in the bank account. So person A withdraws 100 rupees from the account, and he sees the balance get updated to 900 rupees, which makes sense because he withdrew 100 rupees. And at the same time, person B withdraws 200 rupees from the account, and person B sees the balance get updated to 800 rupees, which for him is also correct because he withdrew 200 rupees from 1,000. So the problem here is that in both cases, the balance that is displayed is not correct. The actual balance is 700 rupees because person A withdrew 100 and at the same time person B withdrew 200. So the correct balance should be 700 rupees. And that's what both of them should actually see. But that's not what's happening here. So a database takes care of this problem because it allows multiple people to access it, and it makes sure that the data correctly reflects whatever changes are made, regardless of who makes them or where they're made or when they're made. So it makes sure that the data that is stored correctly reflects all the changes that have been made to it. So if we go back to the bank account example, right? If we're using a database to store the bank balance, then what will happen is after both person A and person B withdraw money, they'll see their balance go down to 700 rupees, which is correct, which is what we want. Another thing that databases allow is that you can make it so you can design the database so that different people can access different parts of it. So let's go back to that example where student A was studying in college X and he was taking computer science and history. So this college administration should be able to access his personal information like the phone number, the address, so on. The professors should be able to access the scores that he's got, his grades, the subjects that he's taking. And also, he's studying two different streams, right? He's doing computer science and history. So his computer science professors should be able to access his computer science subjects. And his history professors should be able to access his history subjects, right? That's another distinction that can be made. And now if we look at student A himself, he should be able to access only his details. He should be able to see his phone number, his address, and the scores that he's got in the subjects that he's taking, but he shouldn't be able to access anything other than that. So in a scenario like this, a database allows you to restrict access so that different people can access only what they need to. Databases also make it very easy to access data. So going back to the example with student A and college X, right? We said that he needs to be able to access only his details, his phone number, his address, and his scores. So if you want to make sure that he sees only his details, if you want to make sure that he sees only his details, you need to filter the data, right? So you're saying show the details only for this student, and he'll see only his own details. Similarly, a manager can look at employees that have salaries greater than some specific amount. So he's filtering the data to see only those employees that have a certain salary. And this is an everyday example. You can search on Spotify for songs that are from a certain genre or by a specific artist. Again, you're filtering data based on what you want to see. And again, you can search for a specific movie on Netflix. So when you're searching for that specific movie, you're filtering the database that Netflix has, and you're searching for whatever you want specifically. And all of this is possible because of databases. Another reason for using databases is efficiency. So databases allow you to quickly and easily add new data and retrieve existing data. So, and a lot of the time, you're storing really huge amounts of data in databases, right? And if you're using something like Excel sheets, it's very difficult to do. So let's look at an example and see, why you can't use just Excel sheets, right? So Excel has a row limit of 1 million, and in each sheet has a row limit of about 1 million. And for example, Google collects around 20 petabytes of data every day. So that's 20 followed by 15 zeros. That's how many bytes. If you are a data scientist at Google and you want to store the data on all the searches that have been performed in a single day, in just one single day, you would need 28 million sheets to store the searches that have been done on Google for just a single day. And this calculation is done assuming that you store about 700 MB per Excel sheet. So that's 28 million every single day, which is a huge number, and it's just not feasible. So that's why databases are used, because you can store huge amounts of data and you can retrieve it and access it very easily. Okay, so we've seen why we need databases. There's a lot of good reasons to use databases. So where are databases used? The short answer is everywhere. So Spotify uses them to store data about what people listen to, what songs and podcasts they have on the platform. Netflix, just like Spotify, stores information about what people watch, and they store information on the shows that they have, the ratings that people give. The police force also uses databases. So if they find a fingerprint at a crime scene, for example, they can match that fingerprint to one that they already have in the database to figure out who it belongs to. The government uses databases to store information about people, the taxes that they pay, things like that. And then there's Amazon as well. That also Amazon stores information on the things that you buy, whether you have a subscription to Prime or not, what you watch on Prime Video, and so on and so forth. Hospitals also store patient information in databases. So if you go to the hospital for an MRI scan, you go to the radiology department for an MRI scan, and then you go to the other department to get a blood test, then all of that information is stored in a database. It's so the MRI scan, the results of your blood test, they're all stored in a single database. Schools as well, they store information on students, the grades that they're getting, the subjects that they're taking. YouTube stores information about what the viewers watch, who they're subscribed to. And this is a newly emerging field. You can also store genomic information, so things like DNA sequences and protein sequences in databases as well. These are also stored in databases. So databases are used everywhere all the time. And an inevitable question that now arises is, why do we store all this data? We've gone to so much trouble to make sure that we can store data in a way that's easy to access, in a way that's easy to use. So the question is, why? And the short answer is, the world pretty much runs on data. So the census data that's collected by the government is used to determine population parameters, how quickly a population is growing, how it's declining. And it's also used to predict the outcome of election results, things like that. You can also use it to predict and analyze unemployment rates, the rate of climate change, the stock market, stock prices, housing prices, job prospects. In the field of medicine, you store data from clinical trials so that you can figure out how effective your treatment is. Is it safe? How bad are the side effects? Things like that. So data is used everywhere for almost everything. So where are these databases stored exactly? Well, you can store it on your hard drive, on your local machine. It can also be stored on a server. So a server is a computer or a system that provides services and data, and people can connect to the server to access those services and that data. So the way that they usually connect to the server is via the internet. There are other ways to connect, but most commonly, it's the internet that you use. So to actually access the database, you use a programming language called Structured Query Language, or SQL for short. So SQL allows you to interact with the database and manipulate the data in it. So let's say you've got your input SQL statement, and that gets pushed to a database. And then the database gets searched, and then your output is usually in the form of a table that contains all the information that you've asked for. So SQL or SQL, it's the standard language that's used to communicate with and manipulate databases. There are many different kinds, different types of SQL databases, but these are the most popular ones. So there's PostgreSQL, there's MySQL, there's Microsoft SQL Server, and then there's also the Oracle database. So they all support SQL, so you can use SQL to manipulate the data in them. So they all support SQL. You can use SQL to manipulate the data within them, and they all offer slightly different features. The one that we're going to be using is MySQL. It's the most widely used, and it's also very easy to set up. So that's the one that we're going to be using in the upcoming videos. So this was an introduction to databases, why we need them and where they're used. So thank you for watching, and I'll see you in the next video.